All right, thank you for joining us today. And in this video, we are going to find the range of values of x for which the following inequalities are satisfied, right? So we are going to go through this, that, this, and then the last one we are going to show that if x is not equal to 1, then this is greater than 2x, right? So let's jump right in. So let me copy the first one to the next page and then we go through together, right? So let's go through this. So we started this absolute value and we said with absolute value, what we can do here is, we can change them either to the piecewise function, plus or minus, or we can square. So like, which one are we going to use? Now, if we are going to use the idea of changing the 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 absolute value to plus or minus, then this one will be plus or minus, this one too will be plus or minus. So this will give us plus or minus, this will give us plus or minus, this is also going to give us plus or minus. So what will be the combination? When I pick positive here, positive, 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 right? It means that I'm going to pick x plus 1 is greater than or equal to x plus 2 plus x plus 3. That is 1. Then I can pick positive, positive, negative. So I'm going to pick x plus 1 greater than or equal to x plus 2 plus, so no, minus, because I'm picking the minus on the last one, x plus 3. Then when I'm done, I'll pick positive minus positive. So x plus 1 is greater than or equal to minus x plus 2 plus x plus 3, right? Then I'll pick positive, negative, negative. X plus 1 greater than or equal to minus x plus 2 minus. So in that order, then you come and pick the last one. Negative, positive, positive, negative, positive, negative, 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 positive, negative, negative, negative. So this is what you are going to do when you want to change it to plus or minus. But this is not what I'm going to do. When we are using the piecewise function to the same idea, when you finish, you need to combine them. But what I'm going to do here is I'm going to use the idea of when we square both sides of the function. So that is what I'm going to use here. So I'm going to square both sides, right? So I'm going to have absolute of x plus 1 squared greater than or equal to x plus 2 absolute plus x plus 3 absolute, all squared, right? So this is what I'm going to do now. Now, what am I going to do again? This can be written as x plus 1 squared greater than or equal to. Now, if you have something squared, like if I have a plus b squared, this is the same as a plus b, right? So I can rewrite this one as x plus 2 absolute plus absolute of x plus 3 absolute, all times absolute of x plus 2 plus absolute of x plus 3. So this is what I'm going to get. Now we learned from some of the properties that if I have absolute of a squared, then this is the same as a squared, like, taking the absolute out, right? Because the performance or what the absolute is going to do, x squared can do it, because the absolute is here to make sure that if a is negative, it becomes positive. The same thing, because this one is squared, when this is negative, still it will be positive. So this is what I can write. So it means that I can write this one as x plus 1 squared by taking out the absolute. Then this is equal greater than or equal to, then I'll multiply this one by this, multiply this one by this, multiply this one by this, multiply this one by that. So we are going to have x plus 1, x plus 2 squared, because this time this will be squared. Then I'll multiply this by this, which we are going to have plus absolute of x plus 2, x plus 3, plus I'll multiply this by this, which is going to give us x plus 2, x plus 3, plus when I multiply this by this, they are the same. So I'm going to have x plus 3 squared. Is that right? Good. Now I can expand this right here, which I'm going to have x squared plus 2x plus 1, right? So how did I do that? I changed Okay, so let me do it so that you see what I did. So this is x plus 1, x plus 1. So this is what I did on the left side. So as we know, because we have absolute squared, this can be written as x plus 2 squared plus this is the same as this. So when we add them, we are going to have 2 absolute of x plus 2 absolute of x plus 3 plus this is also because of the square we are going to have x plus 3 squared. Right. So this is what you are going to get. Now, after this, what we are going to do is we group items. The one with absolute at one side and the one without absolute to one other side. So that's what we are going to do. So when I do that, on the right hand side here, when I expand, I'm going to have x squared. Then this times this will be plus x. Then this times this will be plus x plus 1, right? Then I'll move this one to this side. So I'm going to have minus x plus 2 squared. Then I'll move this one to the other side, which you are going to have minus x plus 2 minus x plus 3 squared, which will be greater than or equal to 2 absolute of x plus 2 absolute of x plus 3 absolute, right? So this is going to give us x squared plus 2x plus 1 minus this one too. I can expand this one. I'm going to have, so when you want to expand this one, you can use the idea of writing this one as x plus 2 minus this one can be written as x plus 3 greater than or equal to. Now we learn from the property that if I have a absolute, b absolute, then this is the same as absolute of ab, right? So since we have absolute here, we can just put them together. So we are going to have 2 absolute of x plus 2 in bracket, then x plus 3 also in bracket. So we can put them into one absolute, right? So that's the idea from there. Let's try and expand this. This is going to be x squared plus 2x plus 1 minus, when I simplify this, I'm going to have x squared plus 4x plus 4 minus, when I expand this, I'm going to have x squared plus 6x plus 9 greater than or equal to. What I'm going to do here is I can send this one inside the absolute. So I'm going to have absolute of 2x plus 2 x plus 3 absolute. Good. Now let's continue. This is the same as x squared plus 2x plus 1 minus x squared minus 4x minus 4. So I'm distributing the minus through the bracket or the parentheses, then minus x squared minus 6x minus 9 greater than or equal to. So now we learned that with absolute, it is the same as plus or minus. So since we've squared both sides, what we are going to do is we are going to change this absolute to plus or minus 2x plus 2 x plus 3. Good. So this is what you are going to get at the end of the day. Now let's see what we can do here. Now this will cancel this, right? So we are going to be left with minus x squared, which is here. Then 2x minus 4x will be minus 2x. In addition to this one is going to give us minus 8x, right? Then 1 minus 4 minus 9 is going to give us, I think, minus 12, right? Because this and this will be 3. Then when I add it to this one, I'm going to get minus 12. And this is going to be greater than or equal to plus or minus 2. Then when I expand this one, I'm going to have x squared plus 5x plus 6. So this is what I'm going to get. Let me multiply 2 by 2. Minus x squared minus 8x minus 12x is greater than or equal to plus or minus, in bracket, 2x squared plus 10x plus 12. So this is what I'm going to get. So now we are at the place where now we can consider the positive sign and also consider the negative sign. right? So now let's consider the positive sign. So plus sign, we are going to have minus x squared minus 8x minus 12 greater than or equal to, when I consider the positive sign, it will be 2x squared plus 10x plus 12. So this is what I'm going to get. Nice. So what I'm going to do is I'm going to move this to this side, move this one to this side, and move this one to also this side. So I'm going to have 2x squared. When I move this one, it become positive, so plus x squared plus 10x, which is also here. Then I'll move this one. I'm going to have plus 8x. Then I have my 12 here plus 12. Then when I move this, I'm going to have plus 12 again. Now remember, I'm moving this to this side. So look at the sign here. The sign here is on the 12. So this is going to be like this, 0. Or if I want to write it this side, it's like this, greater than 0, because I've moved all this to this side. So everything here now is 0. So 0 is greater than or equal to what is here, right? Now I can reverse this by bringing this, like you can see that this here 0 is greater than what is here. So I can write this one as if 0 is greater than what is here, then it means that this what is here is less than 0, right? So I can write this one as, let me simplify this one. I'm going to have 3x squared plus 18x plus 24 is less than or equal to 0, right? Because look at this. This is on the function here, so it should be on this. So this is greater than 0. This here is the same as this less than 0. Right, so this is what you are going to get for the positive sign. So let's try and use the simplify this and then see what we are going to get. So let me bring this one here. Now I can divide through by 3, which is going to give us x squared plus 3 6 18 3 8 24. Yes, I think. Yeah, so now what we are going to do is we are going to try to simplify this. So 2 numbers, a factor of 8, when we multiply we get 8, but when we add we are going to get 6 is I think 2 and 4. Yes, so 2 and 4 will help. So x plus 2x plus 4x plus 8 less than or equal to 0, right? So 2 times 4 is 8, 2x plus 4x is 6. So we are going to factor x out, x plus 2. We are going to factor 4 out, x plus 2 less than or equal to 0. So this is what I did. I just maintain these two. Factor s out, here will be left with x. Factor s out, here will be left with 2. Here I factor 4 out, here will be left with 2. When I factor 4 out here will be left with what? 2. So since we have this and this to be the same, this can be written as x plus 2, x plus 4 less than or equal to 0. So we can pick x plus 2 less than 0. This implies that x is less than or equal to minus 2. We can also pick x plus 4 less than 0. This implies that x is less than or equal to minus 4. Now we are not done. What we need to do is we need to sketch this on the number line, right? So I pick my number line, minus 4, minus 2. So we want to check the interval which the equation is what? Satisfied on the positive side. So when we finish, then we'll go and pick the negative side too as well. So on this side, what are the values or numbers here? We can pick negative 5. So when I pick negative 5, I'm going to plug negative 5 inside this equation, my last equation here, and check if it is true, it is less than 0. Like all numbers here are going to be less than 0. So we are plugging in negative 5. So when I plug in negative 5 here, what am I going to get? Negative 5 plus 2 will give us negative 3. Negative 5 plus 4 is going to give us negative 1. Minus 3 times minus 1 is going to give us 3. Is 3 less than or equal to 0? No. So it means that this is not going to work. We can pick any value between this. We can pick something like negative 3 is in between here. So when I plug in negative 3 here, let's check. Negative 3 plus 2 will be negative 1. Negative 3 plus 4 will be 1. Negative 1 times 1 will be negative 1. Is negative 1 less than or equal to 0? Yes. Yes. So this is true, right? Then the next thing that we can also do is we need to also check for here. So here we can pick like negative 1, 0, 1. So I can pick 0 so that it'll be fast. So when I plug in 0 here, 0 here, here will be left with 2 times 2, 2 times 4, which is 8. 8 is never less than or equal to 0. So this is also not going to work. So it means that our normal line is going to be like this, from this side to this side. Good. That's what you are going to get. And in other words, since this is close, I can write it as this. I can do it like this or like this, meaning that it is close within negative 4 and negative 2. Right. So we will put this one down. We will go and take the negative side. We will sketch the graph and we will combine them before we can get the exact solution that we are looking for. Right. So now let's go and pick the negative sign. Right. So now we are going to pick the negative sign. So let me just pick this one. Then when I go, I'll just make it negative from there. So I just need the negative sign. So let me just paste it here. And don't forget, here we are picking the negative sign. So we are going to have negative in front. So minus sign. Good. So let's simplify. We are going to have minus x squared minus 8x minus 12x is greater than or equal to. When I distribute the minus, I'm going to have minus 2x squared minus 10x minus 12. I'm going to move everything here to the left side. So I'm going to have minus x squared plus 2x squared, right? When I move this one, I get 2x squared minus 8x. When I move the minus 10, I'm going to have plus 10x minus 12. When I move the minus 12 on the right, I'm going to have plus 12, which is greater than or equal to 0. Right? So I move all this to the left. So it will be greater than, nothing will be here, so 0. When I simplify, I'm going to have x squared plus 2x, 12, and minus 12 will be 0. So this will be greater than or equal to 0. So I'm going to have, when I factor s out, I'm going to have x plus 2 greater than or equal to 0. So x is greater than or equal to 0. Then x plus 2 is also greater than or equal to 0. So x is greater than or equal to minus 2. So let's put this one 2 on the number line. I have my minus 2, I have my 0. So let's pick any value here and test it from the last here, right? So when I pick something like minus 3, let's plug in minus 3. So when I plug in minus 3, I'm going to have here, when I plug it minus, I'm going to have minus 3 plus 2 greater than or equal to 0. So I'm plugging in minus 3 here. So I'm going to have minus 3, this will be minus 1 greater than or equal to 0. When I multiply it, I'm going to have 3, which is greater than 0. Yes, so 3 is greater than or equal to 0, which is true. I can pick any value here. I can pick like negative 1, I can pick 1. No, 1 is not here, negative 1 is here. So I can pick negative 1 and plug it in. So let's plug in negative 1 here. I'm going to have minus 1 plus 2 greater than or equal to 0. So minus 1, this is going to give us 1 greater than or equal to 0. Minus 1 is greater than or equal to 0. No. So this is not true. Then I'll pick the last interval. Something here. I can pick 1. Plug it inside this function. So we are going to have 1 plus 2 greater than or equal to 0. So 1 times 3 greater than or equal to 0. Yes, 3 is greater than or equal to 0. So this also work out. So it means that this one, when I'm drawing it, I'm going to have going this way and this one also going this way. In other words, if I want to use the close and open, I'm going to have this one to be like this, right? And this one to be like this. Any of them is true. So now our final solution will be, I'm going to combine this and this on one number line, then we'll find the intersection, and then we will see the solution. So I have negative 4, I have negative 2, I have 0. right? So I have negative 4 here. I have negative 2. This is also negative 2, so the same thing, then I have 0. So then I'm going to try to draw my lines. So I see that in this, I have from 4 to negative 2 combined. And then from here, I have negative 2 going to negative infinity. And then I have 0 also going to positive infinity. So we need to look at the one that graph is what? Intersecting. So we can see that there is intersection here. There is also intersection here. So it means that the solution or the x will lie between -4 less than or equal to x less than or equal to -2. So this is going to be the solution. And this can be written as, when you want to use the interval notation, -4 and -2. So this will be the solution for the first question. So this is so long, right? So I don't know whether I can leave you the B to go through the same process, square both sides like this, right? So let me leave you the B to try. When you finish, I want you to paste your final results either in this form or this form in the comment section, right? So I'm going to leave this one for you. It's the same thing, right? We have this one here, this one here. So you can use the video along the way you are doing it. Go through the same process and drop your final results in the comment section. Let's see who gets it right. Right. So I'm going to go through the C, right? So so try this. Try this. Then I'm going to go through the C. So C. Let's go to the C. So the C, I have this, and this is like double inequality, right? So what I need to do is I'm going to cover this and solve this. When I finish, I'll cover this one and solve this. When I finish, then I'll combine them on the number line and then find out the solution. So first, I want to cover this. So I'm going to have minus 1 x squared divided by x minus 2. So we know that in the normal mathematics that we do, this is divided by 1. So we need to do cross multiplication. This time this time this. But we are not going to do it like that. What we are going to do is we are going to multiply the left and then the right. The left and then the right by squaring this. So I'm going to square the denominator and multiply it by this and this, so that at least when I cancel x minus 2, I will still have x minus 2 on this side. So I'm going to have x minus 2 squared times minus 1 less than or equal to x minus 2 squared times x squared over x minus 2. Good. So when I multiply this here, I'm going to have minus x minus 2 squared less than or equal to, now one of this will cancel this, so it will be left with x minus 2x squared. Let's simplify. On the left, I'm going to have x minus 2 less than or equal to, when I simplify this, I'm going to have x to the power 3, right? Yes, minus, when I simplify this, I'm going to have 2x squared. Right, so this is what I'm going to get at the end of the day. But what if, let's look at this one too as well. What if I just do the thing very straight? So let me see what I'm going to get. If I just do cross multiplication, this times this and this times this, what am I going to get? So let me just go through that one first. Minus 1x minus 2 less than or equal to x squared, right? So when I do that, I'm going to have minus x plus 2 less than or equal to x squared, right? And then when I move this to this side, I'm going to have x squared plus x minus 2 less than, so it will be like this. Clean this. Good. So what I did is I move all this to this side. So what is here is going to be left with 0. And we can rewrite this one as x squared plus x minus 2 greater than or equal to 0. Good. So I think it's good for us to use this instead of the one that we just started with, instead of squaring both sides, because when you square both sides, we are going to have something like cube, right? We are going to have it to be cubed. So let's use this one, just like using the cross multiplication to do it. So let's use this one here. Good. Let's use this one here. So what I just did is I cover this, right? So I pick this one, which is this. This is over 1. So this times this, which is here, then this times that, right? Then I distributed the minus. I move this one to this side. Minus change to positive, positive change to minus, and I have this one here. So let's try and simplify this and see what you are going to get at the end of the day. Now I need to, I need the factors of -2. When I add, I get x, but when I multiply, I get -2. So we can think of this to be plus x minus 2x minus 2 greater than or equal to 0. So 1 times -2 will be this one here, and then 1 plus -2 will be -1. So it means that we need to change it. We need to make this one minus and this one positive, so that -1 times 2 will be -2, then -1 plus 2 will be 1. Good, good. So here I can factor x out, x minus 1 plus, I can factor 2 out, x minus 1 greater than or equal to 0. So since we have this one common, we are going to have x minus 1, x plus 2 greater than or equal to 0. Then we are going to have x minus 1 greater than or equal to 0, x is greater than or equal to 1, then x, this is 2, x plus 2 greater than or equal to 0 will be x is greater than or equal to -2. So the same idea with the number line that we learned, we need to construct the number line, right? Then we use the same process, right? So let's construct the number line here. So I have -2 and 1. So I pick any number here, then I plug it in here. So I can pick -3. When I plug -3 here, what am I going to get? So -3 minus 1 minus 3 plus 2 greater than or equal to 0. So I'm going to have -4 minus 1 greater than or equal to 0. When I multiply, I'm going to have 4. Is 4 greater than or equal to 0? Yes, it is true. Then I pick any number in between this. I can pick something like, can I have 0 here? Yes. So when I plug in 0, let me just do it straight. When I put 0 here and I put 0 here, I'll have -1 times 2, which will be -2. -2 is never greater than 0. So this is not going to work. Then I can plug in something here, which is 2, right? So let's plug in 2. 2 minus 1, 2 plus 2 greater than or equal to 0. This one will be 1 times 4. Then 4 is greater than or equal to 0, which is true. So 4 is greater than or equal to 0. So this is also true. So when I draw it, I'm going to have this going this way and this going this way. The reason why I'm shading this is because of it is inclusive or it is close, right? So this is the one that we covered this. Now what we need to do is we need to cover this and also solve for this. So let's try it and see. X squared divided by x minus 2 less than or equal to 8. So this is divided by 1. I'll multiply this one to this, multiply this one to this. So I'm going to have x squared is less than or equal to 8 times x minus 2. X squared is less than or equal to 8x minus 16. I'll bring them to the left. 8 change to minus 8x, then 16 less than or equal to 0. Let's find the factors of 16. When we add, we get -8, but when we multiply, we are going to get 16. So we can think of 4 and 4. 4 times 4 is 16, and then 4 plus 4 will be 8. So because of it's negative, we are going to make it negative. So x squared minus 4x plus 16 less than or equal to 0. This is going to be x out x minus 4 minus 4 out x minus 4. Is that right? Yes. So when I factor s out, here we'll be left with x, and here we'll be left with 4. Here, when I factor -4 out, here we'll be left with, but here when I factor 4 out, it will be left with 16. But because there is negative here, we need to make this one negative. So when I multiply this and this become positive, right? So this is going to be x minus 4 x minus 4 less than or equal to 0. So x minus 4 is less than 0, x is less than 4. So we can see that x minus 4 is the same thing. So this one is like repeated. So we don't need to pick this one to solve. So this is just 4. So let's plug the 4 on the number line, right? And what we are going to do is we pick any number here, we test it here. We pick any number here, we test it here. So we can pick something like 3. When I plug in 3 here, plug in 3 here, 3 minus 4 is minus 1. 3 minus 4 is also minus 1. Minus 1 is positive. 1 is not less than or equal to 0. So this is out. We can pick like 3 here. No, we can pick like 5 here. 5, here will be 1, here will be 1. Right? So what are we going to get at the end of the day? Let me check it well. If this is 5, this one will be 5, this one will be 5. 5 minus 4 will be 5 minus 4 will be, let me just plug them in. 5 minus 4, 5 minus 4, this is going to give us something like 1, and this is also 1. 1 is not, this one is not true. Let me check the left side again. Left side, we pick something like 3, right? So 3 minus 4, 3 minus 4, this is going to be minus 1. This is also going to be minus 1. And this is going to be 1. Good. So that 1, 2 is not going to work out. That one is not going to work out. So what are we going to get at the end of the day? Let's see what you are going to get at the end of the day. What are you going to get at the end of the day? So this is going to be something like just the one which is 4, because it's only 4 that is going to satisfy the equation. So when I plug in 4 here and 4 here on the boundary, so it's close. So this is what I'm going to get. But let me try and check my result for the other side and see. So what did we do? We said this will multiply what is here, and then we had this one to be less than or equal to x squared. So when I multiply the minus, I have minus here, I have positive here. This one will be x squared. And then when I move this one here, x squared. When I move this one here, positive. When I move this one here, minus. So since 0 is less than or equal to this can be written as this greater than or equal to 0. Good. Then we said that this can be written as this. Is that right? Yes. Good. So we had this one. Then we factored x out, x minus 1. Factor x minus 1. We had this one to be this. So let me test it again from here. I don't know whether this one's supposed to be this. So I pick minus 3. Let me put minus 3 in from this side and see what you're going to get. So minus 3 minus 1 times minus 3 plus 2 should be greater than or equal to 0. So this is going to be minus 4. And this is going to be minus 1. Yeah, this is going to be true. Because this is minus 4. This will be minus 1. Okay. Okay, this is going to be this, and this is going to be that. This is greater than or equal to 0. Let me check my sign again. Yeah, it's right. Multiply this by this, x squared. I'm trying to figure it out. I'm trying to see if I need to it's supposed to be line between -2 and 1, or is it supposed to go this way and this way? That's what I want to check. So minus 1 minus positive, and then x squared here. So move positive 2. This is greater than 0. Good. So everything here is right. Yes. So we have the minus 2 and 1. And when I pick minus 3, minus 3, minus 4, and 1, this is true. And then when I pick 0 in between here, 0, 0, this will be minus. So it's never greater than 0. And then when I pick 2 here, 2, 2, this one 2 is going to be right. So you let me try and combine it on the number line. See, minus 2, 1, and 4. So this one is here. This one is going this way, and this one too also going this way. So the idea here is we're supposed to have one intersection, and I think the intersection is supposed to happen right in between this and this. But I don't know why I'm doing this, but still it's going this way, it's going this way, which is satisfying the equation. But I don't know why. Why? Because when I put negative 3 here, let me put negative 3 here too and see this one is going to be 9. When I put negative 3 here, yes, it is true. When I put 0 here and put 0 here, and put 0 here. Okay, so I think this is what we are going to get, but I'm sure that there should be intersection, which is going to give us minus 2, 1. Like we should have something like this. And then minus 2x, 1, which is supposed to happen here, but I don't know how I'm not getting the results right here. Let me just go through again and see. This is minus 1. Let me check my question again. This is minus 1 x squared over x minus 2. So we have the minus 1 x squared this here. So when I multiply this one by this, I'll have it this, and I have this one too also here, right? So when I move this positive, when I move this minus, this is greater than or equal to 0, which is true. And then when I switch the zeros, this will be greater than 0, right? Then this is right. The solution is right. But still negative 3 is still greater than that, and then fine. So if that's the case, then we are going to say that this has no solution because we don't have, okay, we have one intersection there. Let me see. One intersection here. So this one, x should be equal to 4, which is going to satisfy the whole equation. So let's check when x is equal to 4 if it's going to satisfy the equation indeed. So when x is 4 here, I'm going to have 4 squared divided by 4 minus 2. And what am I going to get? The top will be, so 4 squared divided by 4 minus 2. So I'm going to have 16 divided by 2, and I'm going to have 8. So yeah, indeed, it's true. So when this is 8, 8 is greater than or equal to minus 1, and also, yeah, so it is true. It is true. But let me check when x is 1. If this one is 1 and this one is 1, I'm going to have negative 1. So that one too should work out for me. Because if this one is 1 and this one is 1, I'm going to have negative 1, and negative 1 satisfy the equation. When it is 2, no, when it is 2, it is not going to work out. But when it is negative 2, this one will be 4 divided by minus 4, which is also going to be minus 1, something like that. Oh. All right, so therefore, so if we are basing, if this one is true and we are basing on that, then x should be equal to x and 4. But let me pick something in between this and check it out. If x is 0, yeah, let me plug in 0 too and see. If this is 0, everything goes to 0, and this one too is true. When I pick something like minus 1, minus 1 here, minus 1 here, this is going to be 1 divided by minus, this one too is true. But of course, because of based on what we are looking at, I think this is the perfect one that we are going to use. So now let's look at the last question, and then we are here. We are out of it. We want to show that if x is not equal to 1, then this is greater than 2x, right? So we want to show that if x is not equal to 1, then x squared plus 1 is greater than 2x. So this is what I'm going to do. I'll start by saying that x is not equal to 1, right? Then I move the 1 to the left, which will be this. Then I'll square both sides. So when I square both sides, I'm going to have x minus 1 squared is greater than or equal to 0 squared, which is x minus 1 squared is not equal to 0. But let's look at something here. When x is not 1, then because of the square here, any value that we are going to get on the left will be greater than 0, right? Because even if x here is minus 1, which is going to give us minus 2 squared is going to be positive. So it means that always x minus 1 squared will be greater than 0 when we are taking this one out. So when x is not 1, then always this will be greater than 0, which is true. So now I'm going to expand this. Then I'm going to have x squared minus x plus 1 greater than 0. X squared minus 2x plus 1 is greater than 0. Then I'll move this to this side, which is going to give us x squared plus 1 is greater than what? 2x, which is what we were looking for. So we've proved that if x is not equal to 1, then x plus 1 is greater than or equal to 2x. Right, so this will end the video, but let's check this one again. You can go through the process for me to check. If still you get the 4, let me know. If we are going to, you're supposed to lie between -1, -2 and 1, 2, let me know. See you in the next video.